Hello. Okay, so chapter 9 is just about the same as chapter 8, which is good because you know a bunch of the stuff already. So, but it's got a little bit of a different format. So in chapter 8, we did confidence intervals, right? That was the name of the chapter.
True.
But I think it was estimating with confidence. But the confidence interval gave you a range of values that you could use. And then a lot of times at the end of the problem, it would ask you a yes or no question. You had that yesterday on your FRQ, remember? It was like, is 33% possible? And you guys said no, because it wasn't in the interval. Okay, a hypothesis test basically does very similar math, but gets you to the yes or no question bypassing the interval. I think that significance tests isn't as good as confidence interval. I think it's kind of like a lazy confidence interval. The reason is because at least with the interval, you get some range of values and a yes or no. With these, you just get a yes or no. But a lot of research studies, they do this. So you know a lot of this already. There's just some language to learn today. When I talk about hypothesis tests, I'm going to try to do it in the manner of how our judicial system works. This is going to be a lot of lawsuits, like pre-law type stuff. So if you're interested in law or logic or anything like that, this part will appeal to you. We want to go with an innocent until proven guilty kind of mindset when we're talking about this stuff. Okay, so I think this is probably one of the best chapters to help you learn about how court cases work, actually. Interestingly enough, but it's sad. Okay. I'm going to say significance test sometimes, and I'm going to say hypothesis test sometimes. They're exactly the same thing. It is taking a sample, which should sound very familiar, like let's say a p-hat or an x-bar, to decide between two completing claims, which means you're going to have a yes or no type answer. But the math is very, very similar to what you already done. The claims will be statements about parameters, P and mu. They're going to be exactly the same parameters that you did in chapter 8. Again, chapter 9 is almost exactly the same as chapter 8. Okay. The null hypothesis. The null hypothesis I will very, very lovingly refer to as the HO the rest of the year. So when I say HO, I mean it very lovingly. Yeah, oh, I have that joke coming up. Hold on.
Thanks, Dave.
Yeah. Hold on. Okay, anyway, I'm gonna say ho lots of times and it's probably gonna be funny. But again, whatever we can do to make this stuff funny. Okay, the null hypothesis is the claim we weigh evidence against. Oh, it is on the AP exam. Yeah. Yeah. But it's not hard. There's only one section of this chapter that's confusing, that's not like a math section. The math part of it is extremely similar to chapter 8. Like you're gonna feel like you already know it. Anyway, it's also the statement of innocence. I'm gonna say that word loosely, because I am going to refer to court cases a lot with this chapter. So this is the null hypothesis is assuming innocence, or no change, or current. So nothing interesting is happening here in the null hypothesis. Just how it normally is. I'm really trying to bury this stuff in your brain because it's kind of dry. Okay, and then it looks like this. So you're gonna have P equals some number or mu equals some number. And this is what we'll use for percents, and this is what we'll use for means. What? What? Me trying to be goofy? Okay. All right. The alternative hypothesis I'm going to lovingly refer to as the HA the rest of the year. By the way, for my calculus kids, when I say ho, this is not really an O. It's a not. It's a start. It's like a zero, like a fancy zero, like calculus. Like start. It's a zero, basically. It's not an O, but we put an O there. I don't know. Anyway, zero, start. Like, when you never mind. Okay. Ha. The claim we weigh evidence for. Okay, so I have a room with maybe a few squishmallows in it. And I'm in there and I'm like, oh, same amount of squishmallows as usual. Nothing interesting happening here. So I was the null hypothesis. But then Mr. Talbot comes home and he suspects that perhaps there are more squishmallows than there were in the past. And he's going to try to get some evidence against that claim. That would be the hawk. So the hoe, he's trying to, assume that I didn't go out and buy a bunch of squishmallows, but he's going to try to prove me wrong. Same with the court case. The hoe would be the assumption of innocence. And we're going to talk about two interesting court cases, one of them being the movie Shawshank Redemption and one being O.J. Simpson. We're going to talk about those on Monday. But the innocence, the defender person would be the null hypothesis, and then the prosecutor would be trying to prove the alternative hypothesis that something did indeed happen. So null hypothesis is nothing happened. Alternative hypothesis is, oh, something definitely did happen. Okay. Now, to help us, we're going to call that a statement of guilt. Again, relating that back to the courts. Or some kind of change or some kind of new situation. And in the alternative hypotheses, you're not going to use equals. You're going to use greater than, less than, or not equal to. And we'll talk about that in a bit. Okay. The next bit of notes you're going to write here is about p-value. And to be honest, you've been using p-value all year. I just didn't call it that. That was that 5% threshold that we've been using all year, whether or not something was unusual. That was a p-value. I just never called it that for today. Okay, so you know how on the first day of chapter 8, I said there was gonna be this one sentence that you're gonna have to try to memorize over the chapter. And then it was gonna be annoying because you weren't gonna do it that many times and it's long and stuff. Remember? You remember me saying that? And remember what it's over many.
Over many.
Yeah, okay, yeah. There's one sentence in chapter 9 that you're going to have to remember. Here it is, interpreting p-value. That's why I highlighted it, so you can come back and look at it later. No. Whoop, already messed up. Now, if you're bored, just hold on. I'm going to say a bunch of awkwardly funny stuff in just a few minutes about the hoe. Mhm. Nope. Well, kinda. It's as much the same amount of writing as chapter 8 was. Awesome. Thanks, guys. I wasn't saying that to you. You didn't make a judgment. Pause here. All of the things, you guys know how I work by now, hopefully. All of the things with lines underneath are blanks that you're gonna fill in for each problem. Does that make sense?
Yeah.
So everything I've underlined, we're going to substitute in a piece of the problem, a number or something. And then context will be whatever the problem's about. Okay, so this is what I like to call the recipe sentence. And then for each column, you have a different thing to say for everything that's in blanks. I don't know if this one's better or worse than the chapter 8 one, uh, but it's okay. We're just getting started. We're going to practice this on our example, which is going to be from your cut and paste, your arts and crafts. So hold on that thought. We have this little bit more to do, and then we're going to do the cut and paste part after this. Okay. Remember how I said these gives you a yes or no answer, basically. Same thing we did with confidence intervals. You're just skipping over the interval and you're getting a yes or no answer. Okay. I have a question for you. Is a small probability unusual or a large probability unusual? Okay, think about the shape of the bell curve. Small, right? Small probability of something happens means it's very unusual. Okay, so like Justin. No, I didn't mean to call on you like that. I wasn't gonna ask you to say something. I was just relating to you as my gambling buddy. If there's a, he doesn't actually, it's only me that doing it. Anyway. If there's a small probability of winning money on some sort of gambling game, small probability, that means it's unusual that it happens. That's what I was trying to say. So I like to play slot machines. Unfortunately, the newer machines are what they call more volatile, which means they have more fun features in them, bonuses and things, but they pay out, well, they technically pay out the same way. Anyway, it's, oh, but I don't have a gambling problem. I really don't. I swear you.
Everybody else
It's just that- I don't. I just like to watch other people
I'm not
everybody
addicted.
doing it. Cause I can't, cause I'm too nervous. Anyway, so,
Okay.
okay, but does it make sense to you that, that something with a small probability would happen in an unusual amount of time? So it'd be unusual for something to happen if it had a small probability of happening.
Yeah.
Yeah, does that make sense? Can you guys all relate small probability to unusual? That's just what I'm trying to relate those two things together. Okay. Okay, now I'm gonna say the funny, that wasn't even the funny, awkward stuff I was gonna say. Hold on, there's more. Okay, these are our conclusion sentences for our FRQs, basically. Since our p-value is small, somebody who ever made stats didn't realize how it was going to come out in words. The teachers were going to actually have to say it out loud. Okay, since our p-value is small, we reject the hoe and conclude there is convincing evidence for ha. So you got a small p-value, super unusual that that would happen. Then you reject the hoe and conclude there's convincing evidence for the ha. Okay, let me relate this to a court case. There's a really small chance that that knife with blood on it would be laying on your floor. So we reject your innocence and conclude that you're guilty. Okay. Why do I have to go to a bloody knife and gambling? What kind of lecture is this anyway? Okay. Next. There's only two options. Since our p-value is not small, we fail to reject the hoe. And conclude there is not convincing evidence for the ha. Okay, let me relate that back to my bloody knife situation. Since the bloody knife was laying in the middle of the street in our neighborhood,
it's a much higher probability situation. We fail to show that you are guilty. So, but we can't say that you're innocent either, because we just failed to prove that you were guilty. Do you guys know that this happens in all court cases, by the way? So if they're not found guilty, that doesn't mean that they're innocent. It just means that they didn't get enough evidence to prove them guilty. You cannot look at somebody who is not found guilty and say that they're innocent. Right, true. In the court of law, but that doesn't mean that they were innocent. Okay, anyway, this is my favorite part. Never accept the hoe. Never accept the hoe. You're either going to reject the hoe or you're going to fail to reject the hoe, but you never accept the hoe. Whatever I can do to make this even a tiny bit fun, I will do. Okay. Significance level. Okay, significance level is a Greek letter alpha, and it looks like a little fish guy. Have fun drawing that. It's like half an or 3/4 of an infinity symbol. You knew that one? Oh, good. Okay. Alpha is the boundary to decide if I just wrote the same thing twice. If an observed result could happen by chance. And we've been using alpha equals 5%. So this is the most common one by far. There's also sometimes we use 10%, and then also sometimes we use 1%. And you can really use anything, but those are the three most common. I want you to think about chapter 8 for a second. Do these remind you of anything?
Yeah. 100% confident.
Confidence levels. These are related to confidence levels. And I'm not going to explain that this moment, but it should kind of give you confidence level 5. Okay, now arts and crafts. I'm trying to, I'm very tired, make it more interesting, because this is that. Well, I like to watch TV shows with court cases in this and movies.
Although I'm completely obsessed with Ugly Betty lately. Yeah. It's on Netflix. It's this like girl who's she's not even ugly, but she works like a fashion magazine. She doesn't dress fashionably and like they all tease her and stuff, but she's super cute, adorable, and I love her. It's just like a positive attitude. And anyway, giant braces. It's not even like a new show, it's just newly on Netflix. Yeah, I know, I like those too. I'm watching the Pamela Anderson one right now. Pamela Anderson one right now. I don't suggest it. It's not good. I'm down into the dregs. I've watched so many documentaries. I'm out of good ones. Okay. Let's discuss. Okay, so I want you to think in terms of chapter 8. And in chapter 8, we started working with the 4-step FRQs. Okay, what do we do with the state section in a chapter 8 confidence interval FRQ? What does it start with? That's the conclusion. That's the conclusion. That's the plan. Yeah. Yeah, you say 90 whatever percent confidence interval for P equals portion. Yeah. Okay. Doing great. Perfect. Love it. Great job. Okay. The hypothesis test also has a state. Its state is stating the hypotheses, which makes sense because it's a hypothesis test. So you'd want to state the hypotheses. Anyway. Okay. This particular one here is about means. It's going to feel a little weird because your last chapter was all about proportions and percentages. This particular problem is about means, but they're not having you do any of the math. So A in this question is what you would write for the state for the FRQ. Okay, anyway, state the hypotheses for performing a significance test. Be sure to define the parameter of interest. Okay, the first thing you need to do is figure out if your problem works with proportions or means. This particular problem says the word mean in it, so that means you're working with means. Okay. A company knows that its regular AAA batteries last 30 hours, but like to test if they could last longer. What would be the statement of what is happening currently? What's happening currently? What's the current belief? Nothing interesting is going on. Last 30 hours, fabulous. Okay, so your null hypothesis is going to be that the mean is 30. Okay, now we're going to go to the second part, but would like to test if they could last longer. They want to see if the mean's actually greater than 30. Ah, okay. And then this part is the context of words. So you always start it with the true. If it's a proportions problem, you would say the true proportion. The mean problem, so we're going to say the true mean. And then scroll up. Lifetime of the lifetime of AAA batteries. And I guess we should probably say from this company. 'Cause I'm pretty sure that like Duracell wouldn't really be excited about the Energizer people like testing their batteries. Well, they probably do. Okay. Now, can you imagine that some sort of condition statement was made? And can you imagine that some sort of calculations happened? Okay, so this was the state, the plan we have not talked about, the do you don't know how to do. And then they gave you the answer to the do, which was this. Got it? Okay, so that's like a number you can do some maths on your calculator, click, clickety, 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 and then you're gonna come out with 0.70717. Okay, the clickety, 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 I'm gonna teach you next week. Okay, so interpret this value in context. Okay, so to do this, I'm gonna open my notebook. So I can see over here. Okay, assuming. Okay, and then it says the null hypothesis is underlined there. I'm gonna scroll up here. The null hypothesis is assuming mu equals 30. Are you with me so far? Okay, then it says is true. Comma, there is a. Okay, now what's the next thing? P-value underlined. So you're gonna write the decimal answer there. Probability. Of getting a sample. Scroll back. Okay, then you have to decide if your problem is working with means or proportions. What's this one? Means. Of. Okay, and then you scroll back here. And now we have to actually look at the problem. Again, we have to find our p hat or our x bar back up into the problem. Can you guys find me a sample mean in the problem? Right there? Mm-hmm. Okay, now we have to make another decision here. So 33.93 hours or, and is this one, what's more extreme, more or less? I'm gonna give you a hint with my pointer finger over here. You got greater than. Okay. Just by chance. Oh goodness, I have enough room. And a random sample of 15 AAA batteries. Do you guys see where I got that from? Okay. I guess it's not so bad. It's just a lot of little parts. Okay, last thing for the day. What conclusion would you make at the alpha equals 0.05 level? So it's telling you the boundary is 0.05. Is your p-value greater than that or less than that? Greater, right? Isn't 0.0717 greater than 0.05? Okay, so let's flip back. Since our p-value is not small, don't write this, by the way, we're gonna write other stuff. We fail to reject the hoe and conclude there is not convincing evidence for the ha. Okay, this is how we're gonna write it. This is gonna be our conclude statement or our FRQ. Since our p-value, said not to write it, Mrs. Talbot, I know, I know. Of 0.0717 is greater than 0.05. We fail to reject the hoe. We failed, everyone. We failed. Okay. We do not have convincing evidence. Did I just evidence? I am. Yep, I am. Okay, and then convincing evidence, we do not have convincing evidence for the ha. And the ha says the mean is greater than 30, so what? What is that? Oh, I'm so tired.
Bible. Bible is great. I want to make everybody.
What am I looking at over here? Is there a light bulb thing?
I'm on. I think everybody.
You guys are very nice to me. It's been a really long day. Okay. So I'm really